Good afternoon, everyone. I welcome you all to this second module of fog computing. In the lecture one of fog computing, we saw that what is a fog layer, why do we require it. So coming back to the fog layer, one thing we should be very clear about that a lot of people say that fog is a replacement of cloud. No, it is not a replacement of cloud. It is basically something which we can say as it is complementary to the cloud, and it is required because we know that in last lecture we discussed that every day around 2.5 quintillion of data is being produced. If we continue to upload all that data to the cloud, one lot of storage will be required. Where do we store all this mammoth amount, gigantic amount of data? Second thing, if this kind of 2.5 quintillion of data is to be uploaded to the cloud, bandwidth would be the biggest problem. As we know, as we are aware of the fact that IoT is a platform which has brought together billion of devices connected to the internet platform. It has brought a billion of devices quite near to each other, and they can communicate with any device present in the world at any point of time, that too without much of a human intervention. And if all these devices they start transferring this sense data to the cloud, even IPv6 will not be able to support and facilitate and enable all these devices upload this kind of data. And then another problem is the data confidentiality. A lot of firms, they have quite crucial confidential data which they at every point of time do not want to upload it to cloud. This is also one of the problems. Another is bandwidth. Actually is, we can explore anything, but bandwidth is limited. We have to optimize it to best of its utility. If we are uploading every data which is sensed by our sensors, then it is not a feasible solution. Then it is not at all a feasible solution. Then another thing we discussed about that latency is a big problem. There are a lot of crucial real-time applications or emergency applications which requires a quick response. So the time taken by IoT device to sense the data and upload that to cloud, then cloud to process it and again send it back to the actuator for action to be taken place. And in many situations, the unwanted or unfortunate could have happened by that time. So today in this lecture we'll be talking about, we'll have a more insight of characteristics of fog layer. We'll be discussing slightly in detail what other characteristics are there which are provided by the fog layer. So characteristics of fog layer. Before we move on to discuss the details of characteristics, let us take a look back of the fog layer IoT scenario. So what we have was basically, first one is our what we call as, this is a sensing layer. The first one is our sensing layer, having the what we call as sensors. Let's say these are our IoT devices, set of IoT devices. Let's say these are various subset of IoT devices, or we can say that these are various WSNs which are distributed over a geographical area. Then we have what we call as a fog layer. Here we have certain, we can say that, gateways which are responsible for storing, processing and filtering or extracting the meaningful information from the data which is sensed by these sensors and uploaded to fog layer. And finally we have a centralized cloud layer. And here we have the cloud scenarios, we have the servers, we have database units. So let's say these are our various database units and scenario, and all together we call this thing as a cloud scenario. So basically, as I said that this fog layer is not the replacement of the cloud layer. This is basically complementary to the cloud. This can be used in addition to the cloud in emergency services where the response is quickly needed. Data can be sensed by these sensors, sent to the fog layer for computation, and the response to the actuators can be sent back. Or in certain applications where latency is not a crucial factor, here data can be directly uploaded, and whenever required the response can be obtained from the fog layer. So basically, one thing, as I said, that this cloud layer is centralized, and as this what you call as fog layer is distributed means it is geographically distributed and is placed near to the sensors, or this we call as a perception layer. So it is placed quite nearer to the perception, or what you call so perception or sensing layer. We can now we very well know that this perception layer is very near to the basic fog layer is very nearer to the perception layer, where these sensors are deployed, and they stay. And basically this fog layer is an intermediately processing layer. It is basically an intermediate processing layer which provides computing, networking, and storage services as and when required by the various applications of Internet of Things. Now coming back to the scenario, uh, let us have a look at this scenario again. Now situation is, these are my sensors. Now as we have already discussed that cloud layer is a centralized. Amazon is the biggest player, and the major database, its data storage units are centralized in majorly in America. 70% partnership in world share in cloud processing services is of Amazon. But when we talk about these edge devices, when we talk about this fog layer, let's say this is my sensing layer. So this fog layer is placed nearer to the sensing layer, and cloud is basically centralized for entire globe. But what Cisco suggested, that this layer is placed nearer to the sensing layer, so that every nation can have it 5, 6, 7, 8, 9, depending on, like India might have, for every state it might have some fog processing layer, fog, or for every state, or let's say for all the zones, for all the 4 5 zones of India, it can has its what you call as fogging layer. So basically what we are trying to say, that cloud is centralized for entire globe, but this fog layer is placed nearer to the sensing layer. So the biggest advantage, the immediate advantage of this having fog layer is that being nearer to the sensing layer, it provides the biggest advantage of location management. That is what, as this subset has this fog layer is placed nearer, so it can definitely have, which, let's say this is another subset of WSN which is connected to this fog layer, and let's say this is another subset of what you call as WSN, which is connected to this fog layer. So it is very easy or convenient for fog layer to identify that particular data has been uploaded by which subset of WSNs. Once the subset knows these days these sensors are GPS enabled, or somehow they know their location. So this biggest advantage of fogging layer is that it can sense that particular data is being sent to the fog layer from which particular center. So this location management is the one of the biggest advantage that fog layer provides. So first one is location awareness. Let us see this diagram. Any of the gateway, any gateway can be used by, like if we talk about this particular sensor network, it is transmitting its data to this gateway, and this what you call as a gateway is also being sent data by this particular network. But all these sensors, they transmit their data, they collect the data, they transmit the data to the base station, and base station transfer it to the gateway, and gateway transfer it to the fog layer. So fog layer knows which gateway, reverse engineering, which gateway data has been uploaded. Then the gateway can know which base station has sent me the data, and base station can tell which sensor the data has been sensed from. So this serves a very biggest advantage of what you call as very biggest advantage over the cloud scenario. As this is geographically distributed, it is placed, it is suggested that fog layer is placed everywhere geographically. It can be divided country wise, it can be divided location wise, and every country can has its 5, 10, 15, 20, 15 fog centers, depending upon the requirements, and depending upon the population of the country. Now another advantage, another hidden advantage that this provides is the distribution, in contrast with the as compared to the centralized cloud layer. Now centralization is basically relative. The cloud layer is centralized as seen from the client side. Looking from the organization of the services in the cloud, it is geographically distributed, but not at a scale expected by which the fog layer is distributed. Now cloud service providers such as Amazon, we talk about, have multiple data centers in different regions, but maximum data centers are located in America only, but this is not the case with the what you call as fog layer. So this location awareness, as well as large scale of geographical distribution, as well as this location awareness plus large scale geographic distribution together helps in what you call as helps us to support and to identify mobility requirements of things in Internet of Things. And the biggest advantage, the fog layer ka the biggest advantage, it is very useful for the instances where the actuators, where the immediate actions is required. For example, big hospitals can have their own fog layer, big or graphic area university for that instant. It can have its own personal fog layer, wherein higher end two servers are placed, and whenever some crucial data is to be extracted, it can be transferred, and data processing can be done, and immediate response can be obtained. Same ways the big hospitals like AIMS or Vedanta, they can have their own fog layers and place their servers, and can take the quick responses which cannot be expected, that analysis which cannot be done at the gateway level. So in healthcare departments and emergency services, this fog layer plays a very, very, very important role in emergency services, as well as what you call as this healthcare regions, this fog layer plays a very important role. Now we know that IoT is basically can be connected by wired or wireless networks, but 99% case it is wireless only, but 99% it is wireless only. There are very, we in last semester we discussed a lot of wireless protocols being especially crafted for operations of these constrained devices, that is sensors low, which have lower energy levels. So a lot of protocols to enable this what we call as constrained devices, to operate these constrained devices were developed. 6LoWPAN was one of them, BLE is there, then NB narrowband IoT protocol is there, and many other. This list is endless. So there are a lot of protocols which are especially crafted for these protocols, and we know that these sensors, at times they are so constrained that they even cannot talk TCP IP. That means sensors are what you call as incompatible, are not compatible to transmit data on internet. So these requires converters, so they requires converters or some translator which convert their sensed data into a format which can be uploaded to internet. So this fog layer, the apart from location awareness, second it serves the mobility services. Third, apart from these things, these provides a very additional advantage of interpreter, that is interpretability. So they all these fog devices at the fog layers, they also at times acts as interpreter for these constrained devices or for these sensors. So this is again very important for a heterogeneous IoT scenario where you have n number of devices, in which many of the devices are there which are almost passive. They are only supposed to sense their data and send it to the cluster head sends it to base station. So you require some interpreter sort of device which makes this data convertible, or converts this into a format on which it can be uploaded what you call as onto the net. In addition to this, this fog layer can also helps in filtering the data, or some what you call as lightweight analysis can be done by this fog layer. The scenario is like this: sensor sends the data, sends it to fog, it performs analysis. Once the analysis is okay, it finds something crucial is there, immediate feedback, or can generate some command to operate the actuator to do the needful services. Suppose you have a babysitter at a home and he or she is malfunctioning with the kid. This information to be analyzed by the sensors, and immediate message transmitted on your phone that get back home. So you immediately ask someone nearby to go your home and take care of the situation. In emergency case, they can actually act a lot of things, like the vertical farming patent which you filed. This is like immediately turning on the motor kind of a scenario. But these are very small data sets, vertical farming and all. We are talking about bigger data sets, and in which the immediate response or the feedback or notification to the end user is generated with the help of uh, this fog layer. And last but not the least, this actual scenario what we discussed here can give you real time support there are many applications which requires the real-time support to the IoT scenario. So this actually can give you a real-time support. So the fog layer provides you with a lot of advantages. So couple of them we have discussed here. This list is this is not exhaustive list. There can be many or them which we will keep on discussing as we move ahead in this unit. For characteristics of fog layer, these are the main couple of things which you should remember. Thanks. That's all for this